Hi, myself Kabul, an engineering student from Hindustan Institute of Technology. My research is based on 3D printing technology, which is focused on upside-down 3D printing. As we all know, the additive manufacturing is the next generation of manufacturing. Nowadays, the industry is moving into additive manufacturing. You all may know about FDD and 3D printing, which is one of booming technology in the additive manufacturing industry. There are several types of 3D printing, which include stereolithography, selective laser sintering, fused deposition modeling, and so on. Our project is focused on FDD and 3D printers. The drawbacks with FDD and 3D printers are it required steady frame, constant moving of mass and different height. The cost of framing is high to achieve high-speed printing. The solution is by introducing the upside-down FDD and 3D printing. In this, we move the all gantry parts to base of the printer, so we can achieve low center of gravity, fixing the center of mass by using core XY gantry, so we can increase the printer speed and printing quality, but standard hot in order to tall to fit in the upside down 3D printers, so we modify the hot end. By this we can turn the flow and reduce the distance from heating element. We are able to develop a hot end model, which is based on positron 3D hot end design, which is developed and designed by Kralin. In positron hot end design, they used different materials in heater block, but we able to design same kind of heater block with using a single type material. By this design, we can reduce manufacturing cost and time. We can also simplify the assembly process. By this technique, we can produce compact 3D printer. We can also reduce the Z-axis parts and cost of it. Where consumer segments are print farms, desktop 3D printer, hobbyists and enthusiasts. Our revenue stream is based on business-to-business method. This method is very successful with existing hot end manufacturers like 3D. They are able to change the 3D printer hot end market by supplying hot end to printer manufacturers. We are further developing the project to achieve the mass production level. The version 2 is able to achieve the ease of production with aluminum, and we are trying to produce with copper to achieve high heat conductivity. The project is developed based on ROC 3D printers, positron 3AV 3D printer, which are open source projects. And the project is also open source for the further development of the project. Thank you.